Okay, so as a fun exercise, let's try to answer this problem using basic proportionality theorem. So we have here, okay, so let's try to use the black color. So we have here PA, okay, so this PA all over AT is equal to PS all over, so since this is PS, most likely it's SN, okay? And then we have here blank, okay, so we have here blank NS. Okay, blank all over NS is equal to RT. Okay, let's use a different color. Okay, RT. Okay, RT all over TA. Okay, RT all over TA. Okay, so we have here NS. Okay, so if that's over NS, only this one NS. So it could be NO or ON. Okay. For the third one, okay, so we have PT. Okay, so let's use green. Okay, PT. Okay, so we have here PT over blank is equal to PN. Okay, so this is PN all over SP. Okay, PN all over SP or PS. Okay, so we have here PT, so this has to be PA or AP. Okay, for number 4, okay, let's try. So we have here RT. Okay, RT all over. Okay, let's use blue. Okay, RT all over TP is equal to blank PN. So the blank here has to be ON or NO. Okay. For number 5, okay, let's check first OS. Okay, OS over SP. Okay, is equal to RA all over AP, or it could be PA. Okay, and then number 6 we have here. Let's try to use okay, let's use another color. Let's use orange. Okay, so RT. Okay, RT all over RA. Okay, RA is equal to ON all over OS. There you go. Okay, so for our word problems regarding basic proportionality theorem, okay, so let's try to solve some of these problems. Okay, so we have here, okay, number 1, okay, word problem 1. Okay, so we have here, Aliana wants to build a rotating triangular bed that she shares with her twin sister. Okay, so they want to build a rotating triangular bed. So to make this possible, so they drew a blueprint of the rotating triangular bed given on the right. So find the values of x and y and the perimeter of the entire bed. So using the basic proportionality theorem, we can say that NU, okay, so let's write that neatly, NU all over UR should be equal to NA all over AT using the basic proportionality theorem. And we know that NU is equal to 10, NUR is equal to X, and NA is equal to 12, and AT is equal to 15. Now we can solve for the value of X. So we simply cross multiply, so this will give us 150 is equal to 12x. So we divide both sides by 12. So therefore, the value of x is equal to, okay, so it's equal to 25 over 2 or 12.5 meters. Now, how do we solve for the value of y? Okay, so we already know the value of x here, but to solve for the value of y, it's basically given by this clue that we have here. So Tn is equal to 2y meters, and we know that Tn is equal to 12 plus 15 meters, which is equal to 27 meters. Is that right? Okay, so therefore the value of y will be Ty is equal to 27 divided by 2. Therefore, y is equal to 27 divided by 2, or simply equal to 13.5 meters. Now that we know the value of y and we know the value of x, we can now solve for the perimeter of this triangle. So that's going to be simply the perimeter of triangle NTR is going to be side measurement NT plus side measurement TR plus side measurement NR. So NT is 27, TR is 20, and NR is going to be 10 plus 12.5, so it's going to be 22.5. So if we add all of that together, 27 plus 20 plus 22.5, we get 69.5 meters. So that's the perimeter of triangle NTR, of the rotating triangular bed, which is a very large bed. Okay, so for the second word problem we have here, Juliana wants to build a triangular shaped air mega art statue for her modernistic art complex installment. Okay, so this is one of her art installments. So the measurements are given on the blueprint on the right. Find the value of x and the value of RE. So to get the value of x, of course, we have to use the basic proportionality theorem. So we can write here OR over RD is going to be equal to OE all over EP. Now we know that OR is equal to 30 and RD is equal to 29 pi, and OE is equal to x minus 20, and EP is equal to 18. So using cross multiplication, we can solve for the value of x. Okay, so if we cross multiply, that's going to be 30, okay, times 18 is equal to 29 pi, okay, multiplied by the quantity x minus 20. So what's 30 times 18? So that's going to be 540. Okay, 540 is going to be 29 pi x minus, okay, so 29 pi, okay, 29 pi, okay, 29 pi times 20, so that's going to give you minus 580 pi. Okay, so to solve for the value of x, okay, so that's going to be 540, okay, plus 580 pi. Okay, so it's equal to 29 pi x, and if we divide both sides by 29 pi, okay, we get that the value of x is going to be this one, 540 plus 580 pi all over 29 pi, or simply equal to, okay, so x is equal to 25.93 feet. Okay, so we now solve for the value of x. Okay, so let's solve for the value of RE. So RE is equal to 2y minus 20 feet. But we know that the value of y is equal to OR plus RD, or OD itself. So that's going to be y is equal to 30 plus 29 pi. And therefore, we can simply substitute this value that we have here for RE. To solve for RE, we have here 2y minus 20. So we have that RE is equal to 2 times 30 plus 29 pi, okay, minus 20. So that's going to give you, okay, 60. Okay, we can write that here. Okay, we can write here 60 plus 58 pi. Okay, 60 minus plus 58 pi. And then we have 2. Okay, we'll just remove that parenthesis, minus 20. Okay, so 60 minus 20, that will give you 40. Okay, plus 58 pi. Okay, and using our calculator, the value of RE is going to be 40 plus 58 pi feet. Okay, or if we try to simplify that using the calculator, 40 plus 58 times pi, so that's going to be 222.21. Okay, so that means that RE is equal to 222.21 feet. Okay. Okay, so for this third problem that we have here, okay, so let's read. Marcus wants to create a triangular master bedroom in his house. Given that trapezoid ERAT is the closet room and the bathroom combined, and the triangle RCE is the master suite itself, find the value of A and the perimeter of the combined closet room and bathroom, given that AT is twice RE. Okay, so we want to find, generally, we want to find the perimeter of this trapezoid ERAT and also the value of A. So to find the value of A, okay, we can use, of course, the basic proportionality theorem. So what formula can we create for that? So we can create this formula CE over ET is going to be equal to CR all over RA. Now we know the values of these four variables, okay? So CE is equal to 3A plus 46 all over ET, which is 45, which is going to be equal to CR, which is 4A, all over RA, which is equal to 27. Okay, so if we cross multiply, this will give us 27 times 3A plus 46 is going to be equal to 4A times 45. And 27 times 3, so that will give you 81A. Okay, 81A, and then 27 times 46, that will give you 1242. Okay, so it's equal to 4A times 45. Okay, so what's 4A? Okay, 45 times 4, so that will give you 180A. Okay, so therefore, we have here 1242 is equal to 180A minus 81A. And 180 minus 81, so that will give you a 99. Okay, so 1242 is equal to 99A. And if we divide 1242 by 99, we're going to get 138 over 11 as the value of RA for feet, or simply equal to 12.55. Okay, 12.55 feet is the value of A. Okay, so now that we know the value of A, let's try to get the perimeter of this trapezoid that we have here. Okay, so let's try to erase these parts. Okay, so let's try to draw the trapezoid that we have. Okay, so ER is equal to 2A plus 3. Okay, 2A plus 3 feet. And we have here TA. Okay, so TA is equal to 2 times 2A plus 3 feet, because it's twice. Okay, and we have here ET is equal to 45. Okay, so that's a given. And we have here RA is equal to 27. So we simply just have to plug in the value of A, which is 138 over 11. So ER is going to be 2 times 138 over 11 plus 3. Okay, and if we multiply that to 2, we're going to get the value of TA. Okay, so let's try to do that. Okay, so we have here 138 over 11 times 2. Okay, and plus 3, we get that the value of ER is equal to 28.09 feet. Okay, and if we multiply that to 2, we get that the value of TA is equal to 56.18 feet. And adding all of these four, 28.09 plus 56.18 plus 45 plus 27, we're going to get the perimeter of the trapezoidal room where the closet and the bathroom is found. Okay, so we have here 45 plus 27 plus 28.09 plus 56.18. So that's going to give us 45 plus 27 plus 28.09. So that equals all to 156.27 feet. So this is the perimeter of the trapezoidal room that we have here for this figure that we have.